Hello, everybody. Welcome. MSDOSX last lecture. So I'm going to go over I'm going to give you an overview of iCloud for OS 10 and for iOS. Slides are a little bit rough. I'll be polishing them up before Kevin posts them up online. You'll see at the end I have to fill in a couple of blanks, and then the resources, I have a couple of links to give you for resources. Again, this is kind of an overview. If you want to dive more into this, hopefully this will give you a starting point and an idea of some of the things that you can do with iCloud. After we finish this up, Kevin's going to talk about the projects, so hang out and hang on. So this is supposed to be animated. Yay, but it's not. So I'll just knock these down one by one. iCloud music service. This is what everybody thought initially. Nope. Supercomputer at your fingertips, like Amazon's cloud. Nope. Place to stuff your store store your stuff on the internet. That's getting closer, right? So then it was keep all of your devices in sync with each other. That's much closer to the reality of iCloud. So according to Apple, basically iCloud is just a set of interfaces and a set of interfaces and services to share data, and it's basically a file store is really all it is. But it's a way to keep things automatically in sync, data automatically in sync that you've stored up on the iCloud servers across your various devices, whether it's an OS 10 app or an iOS app. So the very first thing that you have to do if you're going to be using iCloud is you have to decide on one of two storage mediums that you're going to be, you have to decide which of the two, if not both, of the storage mediums that you're going to be using. And there's trade-offs between the two. The first is a document-based storage system, and the second is a key value-based storage system. And I'm going to talk more specifically about that in a second. But keep in mind that there's generally two different ways to store information and retrieve information on iCloud on your devices. So a document-based store on iCloud is Apple defines it as storing data that's used for user-faced data, or data that the user has generated, or large amounts of data that you are generating, or files that you generate. The document-based storage is limited only by the user's account size, how much they've allocated or how much they've paid for, if any, storage on the iCloud service. But it's for essentially large globs of data. We'll talk more about this in a second. Key value storage is much more like configuration data. It's akin to, think, preferences or property lists, which is actually what you're storing up on iCloud. It can only contain property list type data, like strings and dates and numbers and things like that. So in a nutshell, you have two very different ways to use iCloud as a file store. One, globs of data, document, like user interface, user presented data, and large amounts of data that you use, generate, or need to keep synchronized with devices. Or key value pairs, short, small key value pairs, and then we'll talk about the limitations in a second of that. So document-based versus key value pair-based. Very quickly, the kind of data in documents are typically files and folders. The kind of data for key value pairs are property list types, strings, numbers, dates, that kind of thing. When you use document-based storage, you use it for your main data models. In the MVC pattern, your models, all the data that comes out of your models, if it's not configuration data or small little tiny pieces of configuration data that you want to share amongst your devices, that's what you want to use. That's when you want to use the document-based file store for your model, your main model. Settings and configuration data like I said, for the key value pairs. Whether or not you need a file coordinator, and I'll talk about that in a second, you do need that for document-based. You don't need that for key value pairs. I'm just letting you know that now, and we'll talk about what that is specifically in just a second. Trying to locate data that's associated with your application in iCloud. You use NS metadata queries to get document-based storage data retrieved and written from the iCloud, and then you use NS ubiquitous key value store objects to retrieve and set key value pairs in iCloud. How much data can you put in these file stores? In a document-based file store, it's user account bound. Like I said, it's however much the user has if they've signed up for an account, how much they get for free, how much they paid for. That's the size that you're limited by. In the key value pairs, it's 64K. That's all that you can store in your key value pairs. It's also there's also a 64K limit on the actual keys and values themselves for each one of the keys and values themselves. So the limits are the same right now. If they bump up, they may bump up the size of the total amount of data that you can store in key value pairs, but the keys and the values for right now are limited by 64K as well. How do you handle conflicts when multiple applications have changed a document-based file store? You handle it. It's not handled. It's not handled by iCloud. There's a bunch of tools for handling conflicts, but it's not resolved automatically. For key value pair stores, it's automatically the last one that was saved. Whoever made the last update is the current version across devices. Which entitlement the entitlement functionality that you use to access your data securely and specifically for your application, and I'm going to talk about that towards the end. For document-based storage, it's container identifiers that are specific to your application. For key value pairs, it's .kv store identifiers, and I'll show you some of the examples of these later on. When are they synchronized? For document-based, the metadata is synchronized as soon as it's changed. So metadata are smaller representative pieces of a larger document, like time that has changed, or subject, or author, or title, or song name, or artist, or whatever. The metadata gets changed immediately and updated immediately on the file store. For document-based, all of the rest of the data, the large chunk or blob of data that represents, gets updated on an as-needed basis, which makes a lot of sense, right? You create a page document, word layout document that has a whole bunch of figures and a whole bunch of images in it. You don't want that automatically downloading to your iPhone, especially over say a 3G network, every time that document changes, right? So the metadata goes up there. Your devices get notified. We'll talk about that in a second. Then you download the entire document, what's been stored in the file store for the associated document on an as-needed basis. Key value pair stores are updated on a periodic basis. It's generally very, very fast, very, very quick. In the future, hopefully, we'll have a demo that can demonstrate this. For right now, what you can do is after this is over, I can show you where this metadata lives and where these key value pairs live on your Mac or on the Macs here in the lab. And then if you want to use some of the iCloud functionality and some of the framework, you can take a look and see how quickly that updates, and it's actually pretty fast. It's running in the background as a task, so that happens pretty rapidly. How do you check for iCloud being available at the launch of your application, whether it's an iOS app or a Macintosh application? For document, you use URL for ubiquity ... and there's a whole bunch of functions that represent where your file lives in the file store. We'll talk about that in a second here too. You say you give it a known path, and you say give me the URL ubiquity identifier for this file, and if the file exists and iCloud is available on that device, then you will get back a valid URL. If it doesn't, whether the file doesn't exist or iCloud isn't enabled on that device, or the user doesn't have an iCloud account, they'll get back a nil or a null value. You'll use, for the key value pairs, if you're just using key value pairs, you'll be using NS Ubiquitous Key Value Store Sync, which is basically like a which is like a flush command for the NS Ubiquitous Key Value Store object, singleton object. If you make that synchronized call and it doesn't synchronize, or you get an error, you'll know that same thing with the document. It's equivalent to the document-based file store system, where you'll get back a null, or you'll get back if you have iCloud turned off or you don't have your key value pairs set up on that device. Is there a user interface for iCloud Document Store? No, it's not. There's no separate user interface items for iCloud. However, if you add, which you probably should, and I'll talk about cases of where you should add, or you should make user interface changes when using iCloud and iCloud functionality, it should be totally seamless. It should be a very transparent user experience. And it should play nice with other applications, and we'll talk a little bit about that in a second. But there is no specific user interface functionality for iCloud. For key value pairs, it's not even necessary to have the user interface. It's like saying, well, is there user interface on property lists? There's the property list editor, right, which utilizes the property list functionality in the framework, but there's no specific user interface for key value pairs for the file store. So overall, in general, there's no specific user interface functionality that comes with iCloud. However, your interface will probably change and need to be updated if you're using iCloud functionality. And iCloud provides you with a lot of methods and its frameworks to allow you to play nice with other applications. So just a really brief overview. If you're using the document-based file store for iCloud, first thing that you'll do is you'll call URL for ubiquity container identifier. You'll call that method to access your specific container that you've put up on iCloud. And we'll talk about that more about that in a second. But calling this method will give you back either a correct URL, filed URL, or it'll give you back a null. So that's the very first thing that you'll do to make sure that iCloud functionality is enabled. Next thing that you'll do is you'll incorporate what are called file presenters in your data layer. We're going to talk more about that in a second. But that essentially basically tags files with objects that are notified when that file is updated or changes or gets erased. And we'll talk about that in a second. Then you'll be moving your files to iCloud. That includes also renaming or deleting files. Will happen after that. You need to be prepared to handle versioning conflicts. Talk more about that in a second too. You need to be able to search and locate files that you put up on your container. We'll talk about that in a second, and that's all done with the metadata queries. You need to be prepared to provide user interface feedback for iCloud for certain states that iCloud may be in when you've got when you're using document-based functionality, such as, which should be pretty obvious right off the bat, if you have a 3 megabyte file that changes and you're using Pages on your iPad and there's no Wi-Fi available, you need to be able to alert the user that the file's changed and do they want to proceed with downloading it over the 3G network or not. If you're going to have live databases on iCloud, you have to use core data, and if you're going to use SQLite, you have to have core data wrappers and handlers for the SQLite databases. If you don't, and you just use the SQLite interface, you'll end up with corrupted databases, and we'll talk more about this in a second. And then come up with a common document format for your data that is usable for OS 10 and for your iOS apps. You don't want to have really specific functionality. You don't want to have really specific Mac OS 10 data structures and functionality if you're planning on sharing it with your iOS devices. So each one of these pieces under availability, URL for Ubiquity Container Identifier method takes your container ID. We'll talk about this later. It gives you a valid URL if iCloud is enabled and it's found. It binds your container up on iCloud. And this is also incredibly important for the upcoming sandboxing. The sandboxing restrictions. It's your iOS devices are sandboxed right now. It'll become a restriction, and you can't move outside of the sandbox unless it's in very restricted ways. That's outside of the scope of this. Just know that that you have to make this call the first time that you're using iCloud, and that sets up the sandbox for your application, whether it's on your iOS device or your OS 10 device. So you have to use this call anyway, not only just to check to see if iCloud is available, but also to set up your application sandbox. It also makes sure that your container that you put up on iCloud is accessible, whether it's iCloud being turned on or off, if the user's turned it on or off, or you've got intermittent transmission problems. This is where you'll find all that out ahead of time before you start pushing and moving data across devices. If you have multiple container directories, if your application has got multiple containers, and you'll see some reasons for that later why you might want to do that, say to house your databases in one container and house shared application data that you want to share amongst a number of applications in another container, you need to call this once for each container before you start using it. So, file presenters, next step. This is for document-based storage again. So any changes that you make to a file have to go through these file coordinator objects. These file coordinator objects all follow the NS file presenter protocol. Basically, they act as an agent for this file, for this document, for this glob of data. It notifies everybody who's attached to it. It notifies if the file changes. So, if you're going to be using the document-based file storage system, and say you're going to save a user's document, you need to register it with this file presenter, and anybody else who's got access to the document will be notified as soon as that file changes. You'll see where you'll get how to get device updates for new files or things that you're not specifically looking for in a couple of slides. But just know that every one of your document-based file storage system objects have to use this file presenter object protocol. The primary reason for doing this, for adding this overhead, quote unquote, is synchronization. Obvious. It's a very clear, lightweight way to handle multiple document changes and file synchronization. If you have multiple apps that are referencing the same document, you want to make sure that document updates happen in an order and a structured way. Essentially, it's a file locker. It basically says, all right, I'm making changes to this file, tells everybody, all right, I'm going to start making changes to this file, or all right, this file is going to be renamed, or even more importantly, this file is marked for deletion, and everybody who's using these coordinator objects will get notified when one of these events happens. The most straightforward way to incorporate this protocol without having to do a ton of work is to use or to subclass off of UI document. UI document uses this protocol internally. So if you use UI document to represent your data structures for your user documents, then you've automatically got this. You pretty much get this for free.
Worth noting, on OS X, it's NS document.
Good point. So the equivalent UI document is NS document for OS 10. Tag for update. So moving files to iCloud. Once you decide to use it, if you're going to use the document-based storage system, it's exactly the same technology as for local files and folders, and that includes local files and folders for OS 10 and local files and folders that you have on sandboxed iOS apps. You can open, create, read, write, modify files. All of the calls are exactly the same. The only difference is that the file URL, which is kind of the meta umbrella for the abstraction layer for references, pointers to file objects, the only difference is that the URL to access them is different. You still use a URL, file URL object, but instead of it under the hood, which you don't have to worry about, instead of it pointing to a local file or a local folder, it points to a file or a folder up on iCloud. Or the mobile document synchronized folder, and we'll talk about that in a second. So these ubiquity calls are calls that move files from your local sandbox, whether it's on your OS 10 app or iOS app, into the iCloud container directories. And so now, hopefully, you're starting to see this parallel between files and folders, local file folders, and containers, which is a collection of files and folders, document-based files and folders under iCloud. The call for moving files, the method. This is actually all one line. Should be a bullet here. URL for ubiquity container identifier. Set ubiquitous item URL destination URL with the callback of an error. That call is what you use to move a file from a local sandbox to iCloud. It actually is, under the hood, is just using the local file system, the local file system frameworks, and you don't have to worry about exactly what's going on under the hood with the networking and with any of the networking layers or any of that. That's all taken care of for you. The only thing that's different under the hood is that the file URL is now pointing to a place on iCloud or on a place on a locally synchronized directory. So always a danger, right, with keeping documents in sync across multiple devices are conflicts. So here's how conflicts get resolved under document-based iCloud file store systems. The first thing that you do is you'll get the version of the current item at a specific file URL. The next thing you do is you call unresolved conflict versions of item at URL, and it gives you back an array of conflicts. Take a look in the documentation to see what the structure of those data types of those conflicts are. But it's pretty cool. It comes back with an NS array of all of the conflicts that your document has with the document that's up on the iCloud file store. Then your options for resolving the conflict are merging the changed data that's what's changed in both versions. You can also just ignore one of the conflicting versions, whether it's the local version or the version up on the iCloud file store, or very last case scenario, Apple wants you to try and handle these things automatically or gracefully. Kind of worst case scenario, bottom line, if just for safety's sake, if you need the user to make the decision, you can do that here at this point, and you can say, all right, which of these files do you want to keep, and which do you want to overwrite, or which do you want to archive off and save and keep both files. You may have seen that with Lion. When you replace a file in a folder now, you get the option to keep both. That's all using the same underlying technology. Once you've resolved all these conflicts, then if the current file that you have is the winner, it's the most current version, you don't have to do anything. You don't have to worry about it. Any modifications that you make go through the file presenter, then they get updated to iCloud, and iCloud will have the latest version. If the version that if you say that the version that you have is in conflict, but it's older than the version that's up on iCloud, or vice versa, the version you have is in conflict and it's newer, but you want to keep the older version that's up on iCloud, or the version that's being reported is changed after the version that you have, then you coordinate the writing operation to make sure that it's synchronized. The documentation has much more detail on this, but just know that if you have the current version and you've got the latest version, you don't have to worry. If you get conflicts and you make sure and check that everything's cool, you don't have to do any extra work. If you've got an old version or you need to merge, then you need to coordinate the write efforts, and that's all in the documentation. You can also, if you present the user with the choice of keeping both the files, you can also at this point make an archive of the conflicting version, mark whichever one you want as being old or as being new. It's totally up to you, but it gives you that functionality, and gives you the ability to do that and handle that at this stage. Once you've resolved this, and you've resolved it one of these ways, then you set the resolve property of one of the conflicting version objects to yes, and that propagates to the iCloud document-based file store and says, okay, we're golden now. Everybody's had their conflict reserved, and everybody gets back in sync again. So once you put data up there, you may need to track it down. The typical list of contents of directories, the archaic list of contents, parse the list, find what you want, put together a URL. Those days are kind of gone. Now you start using these metadata queries that say, all right, I want the document that's associated with this title and this artist, or the document that's associated with this author on this date that was changed and now has this version. So you present metadata to these query objects, and you get back the file URL. That's the file URL that you'll be using to access the files up on iCloud or locally. There's a lot more in the documentation about this. This is just giving you kind of a brief overview to let you know that it's moving more towards a search-based file system rather than a here's files 1 through 10 and pick which one you want off of a string compare or off of a date compare. There's also methods for retrieving a default that when you set up your application and you set up your container, you can say, all right, I want the default files and folders that are associated with my application, or you can say, I want this other specific container. Now we start seeing the usefulness of having to have multiple containers, because you may want to organize things separately according to a device or according to an application. Say, if you've got, you want to be able to use GarageBand songs in your iMovie app on your OS X device and on your iPad and on your iPhone, you may want to keep separate locations for saving the GarageBand and iMovie documents and, say, the music you may want to share between the two. So you can you can look in the default directories for your application, but then you can also specify specific directories, specific containers that can be shared across applications. There's no specific functionality in iCloud for the user interface changes, but it does. iCloud gives you all the information that you need to play nice and to have a nicely and to have a satisfying user interface experience with once you start moving your documents to iCloud. So normally data is synchronized very, very quickly, and it's really good about, and we'll talk more about this when we talk about the live databases, but it's really, really good about sending the minimal amount that it needs to at a time and only pulling things down when it absolutely has to, or when it absolutely has to keep things in sync with each other or resolve conflicts. So every once in a while, you will get, your device, you may save something on, say you are working on a Pages document on your iPad, and say you're out of range of a Wi-Fi hotspot. You still want that document to be synchronized to your machine at some point. But it may not get synchronized right away. Or you may have a document that you want to work on, but you're outside of a Wi-Fi hotspot, and your local version is older than the version that's up on the server. So you can say, all right, tell me the current state of this resource using this key, these ubiquitous item keys. So this can tell you what state your document is in, your document-based file stored object is in, whether it's downloaded already to that device, whether it needs to be downloaded, if it's in the middle of downloading, how much is downloaded, the progress. So you could present a progress bar if you needed to. It'll let you know whether or not, if you've made changes locally, it's finished uploading or not. So these are ways that you can present the feedback to the user that say, you know, if say they're on a slow connection, it's a large document, you can say, I'm working on updating the document, or if it's in the middle of downloading and the user tries to edit the document, you could present, say, an alert sheet that says, I'm still downloading, here's how much I've downloaded, one moment. So giving user feedback is really, really important. And we'll see another 2 cases where this is in just a second. So in the specific case of not having downloaded the file yet and the user wants to work on it, the file coordinator, the file presenter will block your thread, your main app thread. This makes sense if you think about it. If your file presenter object, the file's agent says, we haven't finished downloading yet, modifying this file, it would just create a conflict or would corrupt the data. It lets your code doesn't have to have any special handling for it on the surface. Your code just works like normal. Open this file, modify it, write this file out to the disk. That's it. The file agent is responsible for blocking your thread, blocking your running app until it's finished downloading. However, having your app suddenly block and pinwheel of death on a user for a few seconds while it finishes downloading isn't the most user-friendly thing to do. It's, in fact, the opposite of user-friendly. So that's what these ubiquitous key value, resource values are for, is to give you information that you can pass along to the user. But Apple doesn't specify, doesn't give you a specific way to interrupt the user or interrupt your application and say and present interfaces that you may not want. You may want to go say do something else or work on something else while it's finishing downloading in the background, and you can do that using this information. So your user interface changes. The 3 main places that your user interface will change if you move to iCloud document-based file storage is when user-generated documents need to be downloaded before you modify them. We just talked about that case. There's also when a version conflict happens and you've decided that you can't resolve the conflict yourself. So you need to be able to provide a user interface that allows the user to specify how to resolve the conflict and what to do after the conflict's been resolved. And then you've also got a user interface element that is definitely necessary, is allowing the user to turn off iCloud synchronization and iCloud usage within just your app alone, and not have to shut iCloud off across the range of the device just because they don't want to use iCloud for your application. So you need to be able to allow the user to shut off iCloud usage for just your application, and that all comes down to user interface as well. So using a live database on iCloud, you have to have your SQLite databases managed by core data. They just have to be. Otherwise, going through the regular SQLite interfaces are going to result in corrupted data. If you look at how core data manages the SQLite databases, it's done by keeping track of log entries of changes to the database. This makes perfect sense when you have a database, a live database that you put up on iCloud that can be modified by multiple readers and writers. CS162 people, this should all sound very familiar. So the way that core data handles it is log entries. That's it. Every time your database changes, it makes a log entry. That's it, and it's done atomically, and it's done up on iCloud. Whenever another application that is using that database that's through core data, another application wants to use that database and wants information from it or modify it, it rebuilds the database on the fly from the log entries, which is straight out of CS162. So bottom line of all of that is you have to use core data to manage an SQLite database if you're using it on iCloud for live database. And this actually comes up a lot more often than you think, because they're really, really handy. And it's really cool to have a constantly in sync live database. But there's a little bit of extra work that you have to do to get it to work correctly with iCloud. Very briefly, because this is actually a much smaller topic, is the key value pair based usage of the file store on iCloud. Like you said before, there's a bunch of limitations. It has to be within 64K. It should only be very small pieces of data. They have to be property list types like strings and dates and times. It's very similar to the local user default preferences. What Kevin had talked about previously, the database, the preps database. The only difference is that the keys are shared over iCloud, meaning that, which is really cool, you can have, once you have make setting configurations, and you make them available as key value pairs on iCloud, then they will stay in sync across your devices. So if you change the type of your favorite default font on Pages, it will be your default font on all of your other devices. Any applications that use the same entitlements, and I'm going to talk about that in just a second, any applications that use the same entitlements can all share the same key value pairs. So that's actually not meant to be a pain in the butt. That's actually meant to be a feature, and as long as you understand and know what entitlements are, it makes a lot of sense, because your default font for Pages may be the same that you want for Numbers or any of your other apps. So you can share all of these defaults essentially across applications, across devices, and they're all kept in sync automatically. The NS Ubiquitous Key Value Store object is how you reference all of these key value pairs. There's a ton of documentation on it. There's a 64K limit on both the keys and the values and the overall data. It's not a replacement for NS user defaults. However, this isn't just a drop-in replacement for that. What you need to do is you need to still maintain your NS user defaults, but when you change them, you can write them out using this Ubiquitous Key Store object. You'll share that with the iCloud, and then when you open up applications on your iOS devices, say, or your OS 10 devices, and you made changes to your key value pairs on your iOS devices, you will read in your defaults like you typically will, but you can also then override them with defaults key value pairs that have been stored up on iCloud.
So it's not a replacement for user defaults, but it's a great way to synchronize it.
Right, exactly. So entitlements, this is the portion that I'll finish polishing up tonight before we upload it. Entitlements are essentially code signing for iCloud, for your iCloud-based applications, whether they're key value pair stores or they're document-based stores. Your applications have to be signed with these entitlements. Not only is it security, like code signing, but it also allows you to share across application and across devices. Typically, that's all walled off, and you shouldn't be pushing this data across devices or shared with other applications. But you can do that using these entitlements. It provides a safe and secure way for your applications to interact and communicate with each other when it comes to user data, user-faced data, or settings configuration. Typically, the entitlements look like this: the team ID and then a bundle identifier. That's all in the documentation. I may put a blurb in here about that, but essentially what it is it lets you have a specific identifier, like your code signing identifier, that is your development team ID, which you can get, it's in the documentation, and a specific bundle identifier for your application or for your suite of applications. There's a tutorial for setting up and using these entitlements. This is the URL. I'll make this link live when Kevin posts the keynote file. If you want to use iCloud, and especially if you want to use iCloud, if you're going to use it, you have to use entitlements. If you want to use it for storing and sharing data across different applications and setting it across different applications, this is a really good way, really good tutorial on how to do that. That is it. Any questions? There probably are. This is, again, another one of those brief overviews, give you an idea of what's possible and what's available with iCloud. Again, the developer documentation is excellent. It's very well fledged out. One of the resources that I'm going to put up on here too are the forums. It's a really good idea if you're going to be using iCloud, especially if you're having problems with synchronization or having problems with data corruption initially. Take a look at the forums. iCloud is still relatively new. When it was in beta, there was a lot of problems with it that people had especially with iOS versus OS 10. So take a look at the forums. They're great for up-to-date information. Kevin.
All right. Well, first of all, thanks for a great semester, everybody. This was a lot of fun. I know it was a lot of work for Glenn and I, doubling all the lectures, and hopefully we made this a lot more interesting, having a lot more content and being able to talk about all these really cool frameworks now. So thank you for that. Hopefully you guys enjoyed it, and hopefully you guys will be willing to come back next semester and continue to retake it and get more and more practice with this, and you're certainly welcome to do that. So thanks very much. So let's, yeah, thanks. Okay, so I've been putting this off long enough. Let's talk about the your final project presentations. So we just this morning finally got everything approved to go down to Apple to present your projects, which is really cool. So we will basically have a conference room with some tables set up, and you guys can bring your laptops and bring your iPads, bring your iPhones, have some demos ready to go, and we'll just have for a couple hours have some engineers and some managers kind of walking through, asking you about your app, having you guys tell us about what you did and what was hard about it, and asking questions. It's really a lot of fun to have people, look at your app and kind of play with it and see, just kind of the work you guys were able to do. Yeah.
So will it be like a year ago where you presented each?
No, it won't be like last year. If anybody was here last year, we had we had more formal presentations where it was you guys got the projector and you guys got to present up on screen. It's going to be more. It's going to be a lot more informal. Just kind of, we're just going to have, a station where you're just kind of hanging around with your laptop and your phone, and just as people walk in, we'll kind of just be coming in and out for a couple hours, just to see what's up.
And giving you time to check out each other's demos too.
Yeah, definitely.
Sure.
And Glenn and I will be walking around making sure that we see everybody so that we can give you guys credit for actually taking the class and, having a project done. So I will be making a Piazza post about who's actually able to come down to Apple. It'll be, we are supposed to be there at 10 o'clock in the morning on Thursday of our week. That's the 8th. And we'll be there until 1. So we'll probably leave Berkeley around 8 in the morning, just in case there's traffic. So I'll make a Piazza post about making sure everybody can come and trying to coordinate rides. I know I have a car, I know Glenn has a car. Hopefully we have some other people that have cars so that we can make sure that everybody can get down there and not have to use public transit, which was annoying last year. I think I had something else, but I can't remember. Oh, another thing, if you have a resume, this is kind of the other part of it. If you have a resume that you'd like to submit to the Apple recruiters, I'll send out her email so that you guys can forward that. If you want to bring in hard copies, to bring them to if there's any managers that are interested in you and you want to talk to them, please feel free to bring copies of resumes. They'll be there to take them. If you prefer to email it, then you can send it to the recruiter or to me and have me forward it. That's another great opportunity that we have here is to be able to go to talk to managers and just kind of, at the very least, network with them and kind of get a foot in the door, or possibly move forward toward actual work there. I think that's everything. So again, thanks for a great semester, guys, and hopefully we'll see as many as you as we can next week. And for those of you who can't make it to Apple, we'll have an alternate time, probably at regular class time that same day. Cool? All right. Thanks.
Cool.